Alright, let's do another problem. So we're going to start with if I is not j, then Eij is equal to 0, since in general we have, and this is something that you can actually find in the text, and they basically just tell you to check it yourself because it's easy to do. Eij equals delta jk eil. And of course here, since j, right, since since here we're doing k is equal to I, and since j is not equal to I, j is not equal to k, and so delta jk is 0, and so it's just 0. Thus, and now what we can do is 1 plus Peij, 1 minus Peij. We can just compute this. And this is a ring, so we don't have to worry about matrices at all. We don't even have to think about matrices. We just distribute, and then we get this p squared term. And the middle two terms cancel, and the last one becomes 0. So it's 1. Likewise, 1 minus Peij. And this is 1. Now for something completely different. Now suppose Zn equals 0. For this part, I didn't use the first part, so I'm wondering if either I did it wrong, which I think is unlikely, or there's some way to do it that uses the first part, but it doesn't seem like it could possibly be easier than the way that I'm going to have, except that there's something that you need to observe. So note that 1 minus z times, if you take the sum 1 plus z squared all the way up to zn minus 1, then this is, okay, so we have the first, when you distribute this to the 1, you get 1 minus z. Then when you distribute it to the z, you get a z minus z squared. And then you'll get a z plus z squared minus z cubed all the way up to, you're going to end with z plus z to the n minus 1 minus z to the n. And so all the z, these two will cancel, that will cancel, everything. This is like a telescoping series from calculus. This is so you're going to end up with 1 minus z to the n, which is 1. And likewise, if you take the sum from 0 to n minus 1 of z to the I, 1 minus c, just you do, it becomes literally the same thing. So hence, 1 minus z inverse is the sum, which is indeed an element of our ring. And so there we go. Again, I have no idea how this relates to the previous part of the exercise. I really don't know. Maybe they want you to prove that like 1 minus z, maybe they want 1 to be the matrix that's just 1 and z to be the matrix that's like z on the diagonal, but I don't, it would amount to being the same thing, because then you just put this element 1 minus z inverse on the diagonal, and then that would be your inverse. I don't know why they put these two together. Maybe it's just because these both are too short to have as separate problems, so we put them together. Who knows? I'm not going to spend more time thinking about it, but there you go. Here's our proof.